Okay, today we're covering area and circumference. You did this last year, so most of what we're supposed to concentrate on this year is the application of the area and the circumference. So we're going to use those formulas to find areas of plane regions and solve applied problems, also with area and circumference. So to refresh your memory, area of a rectangle is length times width. The area of a square is the side squared because all four sides are the same with a square. The area of a parallelogram is base times height. Now remember that the height of a parallelogram is the perpendicular distance between the two parallel sides. It is not the length of a side. And they give you this little diagram so you can see that if we cut off this little what they call red or peachy color section and we move it over to this side, you can see now we have a rectangle, which is why the area is base times height. Then of course we have a triangle, which is 1/2 the base times the height. And then coming to our trapezoid, again to help you remember, okay, we have a trapezoid, which means that at least one pair of parallel sides, and our bases here are given to you as A and B. So what they've done is divided it into two triangles. So they have the area of the yellow triangle plus the area of, they're calling it red triangle, is going to be the whole area of your trapezoid. So we just talked about the area of a triangle is going to be 1/2 the base of A times the height of H. And if we come to the red triangle, again, the height is still H and our base is B. So we're going to have 1/2 BH. And if you do the kind of the reverse distributive property, they both have a 1/2. They both have an H. So we take those out and put them in front, which is where we get that it's 1/2 the height times the sum of the bases. Okay? To refresh your memory on circles, a circle is a set of points in a plane equidistant from a given point called the center. Okay? The radius r is a line segment from the center to any point on the circle, and all radii in a given circle have the same length. The diameter d is a line segment through the center whose endpoints both lie on the circle. It is twice the radius, and all diameters in a circle have the same length. Okay, so an example of finding the distance around a circle. Okay, keep in mind around is our perimeter, but we refer to it as circumference. And you have, in this case, they chose pi d because they gave us the diameter. So that's going to be pi times 40 yards, which is 40 pi yards. And if you put that in your calculator, you will get 125.7. So the distance around the circle is approximately 125.7 yards. Now let's do one involving area, which is the better buy, a large pizza with 16-inch diameter for $15, or a medium pizza with an 8-inch diameter for $7.50. So what we have to do is we're going to have to go figure out which one has the lower price per square inch. Okay, whichever one has the lower price per square inch is the one that's going to give us the better buy. So to find the price per square inch, we need to find out how many square inches each pizza is. The large pizza is pi r squared is to find your area. My radius of my large, if my diameter is 16, my radius is 8 inches. 8 squared is 64 pi inches squared. Put that in your calculator and you'll get 201 inches, square inches. For our medium pizza, again, the area is pi r squared, but our medium pizza has a diameter of 8, which makes the radius half of that, which is 4 inches. 4 inches squared is 16 pi square inches. Put that in your calculator and you will get approximately 50 inches. So that's the square inch of each pizza. Now we have to go take that and figure out how much we're paying per square inch. So if we take the price of a large pizza was $15 divided by our 64 pi square inches or 201 square inches, then we get a price per square inch of 7 cents. Do the same thing for the medium. The pizza price was $7.50 divided by its area, and that gives us 750 divided by 50, which is 15 cents per square inch. So hopefully you can see that the large pizza is the better buy. Okay, next, because they were on lots of different pages, I just gave you all the formulas on one page. If you want to print them out, keep them handy while you work the problems. And I want to do some examples of what you'll see in your homework. Okay, find the area of each figure. When necessary, express your answers in terms of pi and then round to the nearest tenth. Okay, that's one decimal point. So, when you see a figure that's not one of the ones that we have, what we need to do is actually divide it up into smaller figures. Now, it does not matter if you go down or if you go across or however you wish to do it, and that's why it's so important for you to work on it yourself. But we have the area of this figure is going to be equal to the area of, let's call it the small rectangle, plus the area of the large rectangle. Okay, the area of the small rectangle is 3 times 8. The area of the excuse me, the large rectangle. This is 9, and this right here is 3, which makes my whole side equal to 12. So that means that it looks like there's a decimal point in there, and there's not supposed to be, so let me fix that. So the area of our large one is going to be 4 times 12. And we've talked before, does it matter if it's 3 times 8 or 8 times 3? Absolutely not. Okay? So 24 plus 48 is 72. Okay? And remember, there are units in my problem, so I need to have units in my answer. So this is going to be square meters. All right, look at the next one. Again, where you want to divide it is totally arbitrary. It does not matter where you do that. I'm going to go divide mine right here across like this. So now what I have is a triangle and a rectangle. So the area of my figure is going to be the area of a triangle plus the area of a rectangle. This kind of work, when you show this work in your problem, that helps me know what you're doing if you happen to get something wrong. Okay? Now, one of the things that we have to do is we've got to find the height of this. Okay? And if this is 10 and the whole thing is 15, hopefully you can see that those two together, this plus 10 has to equal 15. That leaves this to be 5. And if these two sides are the same and we draw this down perpendicular, it will bisect this segment. So if the whole thing is 24, then you should be able to figure out that that is 12 and 12. Okay, so the area of my triangle is going to be 1/2 the base. The base of my triangle is 24 times the height of 5 plus the area of my rectangle, which is 10 times 24. So we're going to add that up. We're going to have 60 plus 240, which is 300. Again, my units are all in meters, so this, excuse me, 300 square meters. Okay, look at 45. Now, 45 might be easier if you look at doing something like this. Keep in mind that this right here, oh, first color, this circle, or this is not a whole circle. This is a half a circle. But that's a half a circle, and this right here is half of a circle. And hopefully you realize that two halves make a whole. So then let's go to this one. No, let's go with this. And here's another one that is, I'm not doing a very good job of shading in, but you got the idea. There's a half, and here's a half. And again, two halves make a whole. So now what we end up having is actually two circles. So the area of my figure is going to be 2 times the area of a circle plus the area of a square. Because they told us this is a square, so we know that all these sides are 10, okay? Which means, hopefully that tells you that when you get that in half, the radius of my circle is 5. So, 2, area of a circle is pi times your radius is 5 squared, pi r squared, plus area of a square is 10 squared. So 2 times 25 is 50 pi plus 100. And they asked us to give them that answer, so we'll give them that. Our labels centimeters squared. And if we put that in our calculator, we will get 257.1 centimeters squared. This is actually referred to as an exact answer. Okay, so those are adding. Sometimes we actually have to subtract. So when you look at this problem, hopefully you can see that to get the area of our shaded region, we're going to have to take the area of the big triangle and take out the area of the small triangle. So, area of my big triangle, 1/2. The base, what's the base of my big triangle? That's this whole thing. So that's 24. 1/2 base times the height. The height is 12 plus 6, which is 18. And the area of the small triangle is again 1/2 the base. My base is 8, and my height is 6. So that's going to give me 216 minus 24 equals 8 pi. I'm sorry, there's no pi involved in that. Equals 192 square centimeters. Alright, let's look at our circles. We have a big circle, and this is going to be a diameter. I'm not doing a very good job of drawing it, but all the way across. Okay, this is the center of my circle. So if each of these have a radius of 2, then you should be able to tell me that the radius of the big circle is 4. So the area here is going to be area of the big circle minus the area of the, actually 2. We have 2 times the area of the small circle. So the area of the big circle is pi times your radius is 4 squared minus 2, area is pi, and the radius of the small one is 2 squared. So 4 squared is 16 pi. 2 squared is 4 times 2 is 8. 16 minus 8 is 8 pi. They said leave your answer, find the area in terms of pi. So I have pi in my answer. I'm going to leave it, but I'm going to make sure that I have my units on there. So that's 8 pi square centimeters. And to make sure that I have room, let's see if I can, it's not going to let me do that. Let's see if I can do that. Make that a little bit smaller next to that. And now for the next one, Okay, looking at the figure, and feel free to pause if you need to, so you can think about the problem before I actually do it. But this one, I'm going to have the area is equal to, take that piece back. This time, I don't have a whole circle. Hopefully you can tell that this is half of the area of a circle minus the area of a triangle. Now, area of the circle, 1/2 pi. Uh-oh, what's my radius? My radius, I gotta figure out this length. So hopefully they've given me a right triangle and you realize that 6 squared plus 8 squared is r squared. That's my radius. So 100 equals r squared, which means that r is equal to, actually I shouldn't say r because it's not r in this case. Hopefully you're telling me way back when that this is the diameter because I'm actually going all the way across. So the diameter of my circle is 10, which makes my radius 5 squared. And the area of my triangle is 1/2. Remember, the base and the height always have to be perpendicular, so it's going to be 6 and 8. So this is going to give me 25 pi over 2 minus 24. And they said leave it in terms of pi. So that's inches squared. Okay, one last problem about fertilizing your lawn. Okay, this last problem is very applicable because you may in someday own such a lot. Okay, the lot in the figure shown, except for the house, shed, and driveway, is lawn. One bag of lawn fertilizer costs $25 and covers 4,000 square feet. So they want us to determine the number of bags of fertilizer needed for the lawn. So hopefully you can see from that we need to find the area of everything, but we got to take out the house, the shed, and the driveway. That means that the area that we're looking for is the area of, let's say, the area of the lot, which is a rectangle, right? It's the area of the rectangle minus the area of, let's do this. I don't want to use rectangle. Let's use letters to represent those. So that's the area of the rectangle minus the area of the house minus the area of the shed minus the area of the driveway. So that gives us area of the rectangle is going to be 500 times 200. The area of the house is going to be 60 times 100. The area of the shed is a square, so that's 20 squared. And the area of the driveway is going to be 20 times 100. So if you put all that in your calculator, we'll go ahead and show each one. This is 100,000. 1, 2, 3, 4, 1, 2, 3, 4 with a 10. So that's 100,000 minus 6,000 minus 400 minus 2,000, which gives us a total of 91,600. So that's square feet. And if I need to find out how many um, bags of fertilizer, then I got to take that 91,600 square feet and divide it by 4,000 because I need to know how many bags that I'm going to get to cover that. Okay. Another way to look at that, if you like, would think of our dimensional analysis that we've done before, and you can know that one bag of fertilizer is equal to 4,000 square feet. Okay, so that's why we're dividing. So 91,600 divided by 4,000 is actually 22.9. So that's 22.9 bags, which means how many bags of fertilizer do we have to get? We have to get 23 because we can't buy a part of a bag of fertilizer. And the total cost is going to be to take 23, 23 bags times $25 per bag of fertilizer. Again, our bags cancel. 23 times 25 gives us a total of $575. Again, great application for you when you have your own house someday. So work on those, and if you have some trouble, come see me.